Hi, my name is Sam Gallagher,
And my name is Nate Marks.
and we are doing the facility layout for an electric vehicle assembly line. In our video today, we will discuss the following agenda. We will let you know about our previous progress in 481, define our new scope, our problem statement, the design we followed, some economic decisions that were made, our recommendations to our client, and finally some possible impacts our project may bring. Previously, in our 481 class, we had performed a literature review to acquire the necessary background dealing with electric vehicles. We also designed and analyzed the battery pack assembly process for Sharpell's vehicle. We provided recommendations for layout and process solutions of the battery pack assembly and began planning the next stages of the project development in 482. Sharpell Technologies wants to create a high-end, fully bespoke electric car. Though the company is still in the design phase of the vehicle, they have begun talking to investors about the manufacturing and assembly of their future electric vehicle. With little knowledge about facilities planning, they need assistance with the design of their manufacturing assembly line. Right now, they plan on producing around 150 cars in their first year, with the hopes of growing to producing 400 high-end cars by their fourth business year. Our problem statement, therefore, is Sharpell Technology needs to determine the manufacturing processes and required facility space for the assembly of an electric car in California. Because Sharpell Technology is still in their developmental stages, we were tasked with determining the assembly process of an electric vehicle. We decided to take the systematic approach of facility planning to come up with a solution to our problem and begun looking at the big picture by determining the various departments associated with the assembly of an electric vehicle. The departments we created included the chassis and battery pack, the powertrain, suspension, auxiliary systems, the body and wheels, the CPU and wiring, and finally the interior department. Then we researched what steps would need to take place within each department.
Here we have a flow chart that we created of the car assembly process. It begins in the chassis and battery pack department with the delivery of an outsourced chassis to which the battery pack is then inserted into. After the battery pack is put in the chassis, it is moved to the powertrain department where the motor, gearbox, controllers, and axles are installed in that order. Next, it moves to the suspension department where the upper and lower A-arms are installed, then the uprights with bearings, the shocks, and the brakes. After suspension, it moves to the auxiliary systems department where the radiator is installed, then power steering, the brake lines, and finally the cooling system and fan. After auxiliary systems, it moves on to the body and the wheels. The body panels are installed and then the wheels are installed and it becomes a rolling chassis, so there's no more need for a push cart. After the body and the wheels are added to the vehicle, it moves to the CPU and wiring department where the main CPU is installed, the internal wiring is connected, and the dash wiring is installed. Lastly, after the CPU and wiring, it'll move to the interior department where the insulation will be installed, the dash and vinyl leather, the carpets, the console, the inner panels, and then any of the finishing trim that needs to be added. This is just a bird's eye view of a linear layout of the assembly process of the electric vehicle. It's just an easy way to give our client a visual aid to help him see what happens along the assembly process and then show the relationships between the departments. It also incorporates a couple quality checks that were discussed with the client as well. Once the assembly process was established, we then needed to determine the time each task would take to calculate the number of workstations needed, the bottlenecks, and the approximate employee requirements. To do this, the method of triangulation was used, in which we viewed expert videos of people performing the tasks, our client's knowledge, and mock trials where we performed each task as if we were on the assembly line doing it to the car. Along with calculating the number of workstations, we were able to estimate the square footage needed, taking into account aisles, equipment, and the size of the car itself. Based on our client's 400 car output objective after 4 years and our total times, we were able to find a takt time of 9.375 hours per car, so just over 1 8-hour shift. Here we have a bird's eye view of the SketchUp model we were able to create once we had the times calculated as well as the square footage estimate. As you can see, the chassis and battery pack department is represented by red flooring. The pink floors are the quality checks within the facility. The blue flooring is the powertrain department. The yellow flooring is the suspension department. The auxiliary systems are represented by the purple floors. The body and the wheels are the green floors. The CPU and wiring are the orange floors, and although you can barely see it here, the interior departments are represented by gray flooring. In terms of our recommendations for this facility layout, all the assembly processes were found to be standard between the cars produced until they reach the interior department. Therefore, due to the calculations, we only need one workstation for each process until the vehicle reaches this point. However, the time for each interior function is variable, and it will certainly take at least 1 day to move through the entire department. Also, this is a bespoke luxury vehicle, which allows the customer full control of the design, which could require special components and tooling in the interior departments. Therefore, we recommend 4 workstations here. We were able to determine our layout widths based on the allowance between columns of 25 feet, which also fits our requirement based on worker walkways of 3 feet, our 6.5 foot chassis, and our inventory size of 6.5 feet, as well as a buffer area around the chassis and vehicle for installation, and another 15% clearance. Our lengths were determined based on inventory sizes needed, how many machines would need to be used, as well as our clearances. Based on our takt times up to the interior stage, we found we would only need 1 workstation with 2 workers to meet our client's 400 car per year requirement 4 years into the future. Because we determined interior workstations would have a central spot for our car, where each step would be done to it, we extended our 25 by 27 feet square footage to 25 by 40 feet to account for extra supply storage to accompany each step in the interior process.
One major decision that must be made when creating a facility is what mode of material handling will be used. We wanted to do an economic analysis based on 3 options: an assisted pushcart, a conveyor system, as well as an AGV system. We had to consider the output Sharpell was projecting to manufacture each year, which was relatively low. In many assembly lines with huge outputs, pushcarts would not be a feasible option based on the speed required between each station. However, because time between stations would not be a huge factor, our economic analysis showed that an assisted pushcart system would be the best economic option for Sharpell Technology to implement for their material handling of the assembly line until the vehicle was on the moving chassis. With the creation of our project, we did have some impacts that we needed to consider. First off, we needed to consider the social impact, which in this case was a positive one. By creating a new manufacturing plant, we would be therefore creating jobs for citizens of the nearby town which we would select. By keeping the output low and relying on human labor, it should be welcomed by the working class. Also, another impact that must be considered is the environmental impact. We advised Sharpell Technology that due to his company striving for a totally electric vehicle, he should try and keep a green mindset in selecting manufacturing machines. This, therefore, would maintain the company's image as an environmentally friendly vehicle manufacturer. Finally, we would like to thank you for your time, and we look forward to meeting you and addressing any questions you might have next week. Thank you.